Welcome to this podcast on AUTOSAR transformation. This is part 2 of 3 parts where we look into lessons learned from introducing AUTOSAR. My name is Christoph Ebert. I'm the Managing Director of Vector Consulting Services, and I will guide you through this podcast. Now, this podcast seems to talk primarily about AUTOSAR, but specifically this second part is also a good overview into what are the experiences in architecture transformation, that is moving some existing content like functions in an existing architecture into another environment, which is not exactly easy to achieve, especially with the challenges on configuration management, etc. So let us look into some of the experiences which we gained in working with numerous companies on introducing AUTOSAR, but also working in task forces to recuperate from problems which had been created by not carefully preparing the AUTOSAR transition. A first and key observation is that we see in almost all companies insufficient architecture focus. What do we mean with that? Often there's simply not enough education about architecture, how to model, how to analyze dependency, how to set up KPIs for architecture, etc. This is understandable because until very recently, this was not even really tangible as a discipline in itself. We had, of course, architecture evaluation frameworks, but not exactly things which were presented and taught in university and done in companies. With the advent of more modern modeling, and especially also the need to make very clear dependency analysis, we have today in most companies a profound understanding about the need for architecture documentation, which now has to ripple in all of these legacy environments, but also in the heads of all the engineers. For instance, we sometimes see a specific ivory tower-like department, which is called architects. Well, that's helpful because the architect could then at least give some governance, but like in building, in construction, the architect has to be everywhere. And that means also in each of the engineering projects. And that means in software specifically, the engineers need to have some understanding about architecture. We're not asking that they change the architecture, but they should be aware about interfaces, performance, quality requirements, etc. So let us look into these challenges with insufficient architecture focus. Often it's thought that due to having a good AUTOSAR stack and framework with very precisely defined interfaces, both classic as well as adaptive, the existing content like functions in an, let's say, AUTOSAR classic environment can easily transferred into adaptive. Well, that's not exactly possible, first of all, because you have the move into SOA, but also even if you have existing building blocks which you could move, you still have to consider the environment. The tools alone will not do the job. You have also to prepare the signals, etc. Often also there is no dedicated architecture preparation. AUTOSAR is used with the specific interfaces, and on top the applications are modeled and developed, but often inconsistently, especially where you have supply chains. The OEM might have and often have their modeling, their consistency for the whole vehicle, but then they have maybe dual sourcing. They go into different suppliers and do not give those the full picture of the dependencies. Also, and that is something which we see most frequently, there's not enough documentation of architecture. Again, theoretically, no issue. We have a wealth of really good modeling tools, such as Revision, such as Rhapsody, etc. However, they are often not completely used. We have seen situations where architectures have been drawn with drawing tools, no dependency analysis, no syntactic and semantic checks. And that's, of course, not only a waste of engineering effort, but most of these drawing tools, even if they support all UML and SysML libraries, are not suitable for a complex system like AUTOSAR, where you, for instance, have to ensure interface consistency along a very complex chain of different components. Second topic is often the architecture does just not fit. We have drivers which lead into specific behaviors which maybe later on have not sufficient performance, which would not present the necessary cybersecurity constraint. So many of the architectures which we have seen in projects often lack clear architecture guidance, no design patterns, no real clear, consistent design principles. And often design decisions are not made explicitly. So you have, in other words, a modeling on the level of systems analysis, of requirements analysis on a high level, where we see building blocks, we see maybe even certain diagrams like sequence, etc. Then we dive immediately downwards into specific code and related functions, but the middle layer, which is defining the building blocks, the deployment, the different viewpoints from a technical perspective, is not sufficient. Finally, and that's the typical symptom which we see in practice, is insufficient quality. It starts with not defining the requirements in a measurable way. We see something like a performance requirement with a reaction time, but not sufficiently broken down with respect to real-time behaviors. We see statements like we have cybersecurity, functional safety, portability constraints, but not defined in a way that you can really implement those. And we see many violations of the AUTOSAR conventions. There are a lot of tools which are often used along the way how AUTOSAR software is produced. And in this tool chain, which often has also a lot of homemade tools, we see a lot of internal conventions, which is good, but which often are not consistent. Signal names might change. Signals might have, after a change, the same name as before. So there is no visibility about which is now the version, which is the specific variant. And we see also insufficient link into the right side of the V. That means, how do we verify? How do we analyze architecture? How do we validate that specific architecture patterns are really implemented in practice? Which means that often we see delays, inconsistency during integration. We see safety cases which can hardly be updated, and that creates rework and, of course, also delays. So consider the technical debt when you introduce architecture changes. Don't rush into the coding. Make sure your architecture is well documented and suitable for reuse. What we learn from our task forces can be summarized into a few specific guidance. We see insufficient process and roles. That means make sure that your agile setup, which is today quite normal, has still a good consideration of ASPICE needs, such as configuration management, traceability, project management, testing, etc. Make sure you have architecture coherence. That means use the AUTOSAR architecture, but also make sure it fits to the environment in which you implant this AUTOSAR from an ECU or multiple ECU perspective. Make interface agreements. Interface agreements mean to have clearly specified interfaces which you share with suppliers, which you share across departments, which are kind of invariants. A major trouble in the task forces which we have been working was that interfaces have been changed unilateral. That means only on one side without communicating. With SOA, this gets even more challenging because here the services have not only their specific descriptions, but also general repositories which have to be kept consistent. Quality requirements are not balanced. Introduce trade-off analysis. Make sure you evaluate performance. We have seen projects where somewhere in the middle, design decisions were done with timing, for instance. Somebody saying, well, we need a 300 millisecond response time. Looking to the environment, looking to the content, this decision was neither justified top-down nor clean implemented inside the building block, for instance, exception handling, etc. And then, of course, build the necessary competencies, build architecture competence. We are training in many companies the software architects. And we do that not from a, let's say, university perspective. We do that hands-on. We do that specifically for the job. And we ensure that people have the sufficient architecture understanding which they need from a systems engineering perspective. And finally, make sure that you have scalability, that whenever you work, for instance, in adaptive AUTOSAR, that you use modeling, that you use tools like DaVinci, like others, and also keep consistency with your own tools, with external commercial off-the-shelf tools, so that they fit together, that you don't have interface inconsistencies, that signals are aligned, etc. To summarize, an AUTOSAR introduction or migration from classic to adaptive is a transformation project with the dimensions of process, technology, and competencies which have to be lined up. Our recommendation here is use the vector health check, which has been coined around our AUTOSAR experiences to provide you with good insight into AUTOSAR. And with this, I want to thank you very much for listening to part 2 of this 3-part introduction to AUTOSAR and AUTOSAR migration, and look forward to hear from you. We can be reached with www.vector.com/consulting. Thank you very much and have good success with your AUTOSAR transition.